Okay guys, second video for chapter 21. Now we're going to actually start to do our confidence intervals with this one. Okay, so confidence intervals for the difference between two proportions. So when comparing two proportions. So when data comes from two random samples or two groups in a randomized experiment, the statistic or randomized sample, the statistic of the difference between the two proportions is our best guess for the value of P1 minus P2. We can use our familiar formula to calculate a confidence interval. So the statistic plus or minus your margin of error, so that's your critical value times your standard error. When the independent condition is met, the standard deviation is going to be this formula, which we saw in the last video. So because we don't know the values of our parameters, we never do with our confidence intervals, we do with our significance tests, but not here. We replace them in the standard deviation formula with the sample proportions. So the result is the standard error, which we're very familiar with this idea from chapter 18. Just now that because there's two proportions, you're dealing with a standard error of 2 for this. If the normal condition is met, we find the critical value for the given confidence level from the standard normal curve. Our confidence interval for the difference between them is as follows. Okay, so this is pretty much just reiterating the same thing that it said in the last slide, with reminding you all that you do have to check your 3 conditions to be able to run a confidence interval. And with your large counts, checking to see if it's normal, you have to do that for both, just like I did in video 1. So let's go ahead and run through a quick confidence interval and then be done with this video. So as part of the Pew Internet and American Life Project, researchers conducted 2 surveys in late 2012. An extra 0 there. The first survey asked a random sample of 799 U.S. teens about their use of social media and the internet. A second survey posed similar questions to a random sample of 2,253 U.S. adults. In these 2 studies, 80% of teens and 69% of adults said that they use social networking sites. So we're going to calculate the standard error of the sampling distribution, and then we're going to use the results to construct a 95% confidence interval. Okay, so for part A, I have to find my standard error, so I'm going to use this big, long formula. By the way, this is on your reference sheet for your test. You just have to know where it is and how to use it. Okay. So sample 1 was 80% of teens, and there was 799 teens versus 69% of adults, and there was 2,253 adults. Okay, so that's going to give you a standard error of 0.017, okay, where your P1 was the true proportion of teens who use social media. Okay, and your P2 would be adults using social media. Okay, so I am going to have to check my conditions here. Okay. So it's definitely random. They say that it was a random sample of 799 teens, and it was a random sample of 2,253 adults. So your random condition is definitely met. Let's talk about independent. Okay, so we'll check our 10% condition there. So 799 teens is definitely less than 10% of all teens, and 2,253 adults is definitely less than 10% of all adults. So we're good with independent. Now our large counts. I'm going to take a little bit more work here. So our number of successes for our first proportion, or expected successes, would be about 639, which is definitely greater than or equal to 10, which means that the number of fails would be about 159, which is greater than or equal to 10. So our large counts is met for our first sample. We have to check it again for our second sample, our second group. So our 2. Okay, so that was 2,253 adults. Success, we're expecting 69% success. So that's 1,554, which is greater than or equal to 10. So then that would bring us to our fails. So 2,253 times 0.31 would be 698, which is also greater than or equal to 10. So our large counts condition is met, and so we know a normal approximation would be able to be used in this situation. Okay, and so now we are ready to run our confidence interval.